Right. So, previous class we have done the maximal flow problems, one side of this, that is the capacity of a cart. So, very quickly if we just do a review of this, then cart is a cart set which separates the source from the sink. So, if you look at the slide, in this particular example, C1 is a cart, C2 is also a cart, C3 is a cart, but anything that does not separate the source from the sink is not a cart. And we have also understood the concept of capacity of a cart. The capacity of a cart is equal to that if a particular cart separates the network into two sets of nodes, say P and P bar, all the edges which are existing between P and P bar, capacity of those edges. So, some of them will be like 1 4, 2 4, 3 4, but some could be something like 5 3, where 3 to 5 forward flow capacity and 3 to 5 backward flow capacity should be taken, because it is coming 5 to 3 and not 3 to 5. So, one has to be very careful which capacity are we taking in the computation of the cart. So, that is what is required to compute the capacity of a cart, and then we have learned that there is a theorem called maximum flow minimum cart theorem, which is based on the theory of constraints, and the essential idea is that maximum flow possible in a network is equal to the capacity of the minimum possible cart in that network. This we have already seen. Now, let us go ahead and do a problem from scratch. So, consider the graph given below in terms of edge, forward flow capacity and backward flow capacity. Assume lossless flow and infinite node capacity for each node. So, draw the network flow diagram and find the maximal flow from node S to node T using the network flow algorithm. So, let me note down the problem and then let us draw it. So, S22 is 90, S23 S23 is 60, S24 is 20, 2 to 5 is 60, 3 to 4 is 43, then 3 to 5 is 2 3, 3 to 6 is 50, 4 to 6 is also 50, 4 to 6 is 50, 5 to T is 50 and 6 to T is 12 0. Maximal flow algorithm. So, this is the problem that S22 90, S23 60, S24 20, 2 to 5 60, 3 to 4 43, 3 to 5 23, 3 to 6 50, 4 to 6 50, 5 to T 50 and 6 to T 12 0. So, first task is to construct the network diagram. So, you see we have ST and 2 3 4 5 6. So, let us draw S here, 2 here, 3 here, 4 here and 5 here, 6 here and T here. Then S22 we know it is 90, S23 60, S24 20 225 60 324 43, then 325 23, 326 is 50, 426 is also 50, 52T 50, 62T 12. So, see, network is constructed, right. So, to check this network, let us look at this diagram, So, more or less we have drawn the same diagram. So, that is the diagram that is drawn. Now, question is that if this is the diagram, that is the network diagram, the flow is coming at source and flow is going out at sink. So, can we apply what is known as the maximal flow minimum cut theorem? Maximal flow minimum cut theorem, can I apply? So, if you want to apply, then you have to know the different cuts and their capacities. So, what is the capacities of cuts? What are the different capacities of cuts, right? So, what is the capacity of the cut S? S is a cut. What is that cut? Just look here, it will cut S on one side and rest on the other side. So, can you see, if I have a cut here, it should be 9, 6, 15 and 17, the capacity should be 17, alright. So, you see, you have to keep exploring. So, what is the capacity of S2? S and 2 on one side and rest on the other side. So, can you see that it is 14? It is 14. Why 14? Because if I draw a cut here, let us draw this cut, right. Then in this cut, the total flow is 14, right. So, this is the cut S2, this is the S2 cut, right. I have drawn very light just to do not make the diagram too hazy, right. So, this is 14. Then other cuts are, many other cuts are possible, but one has to be careful. I mean, there is no need to really clutter all of them, because let us draw this one. What is its capacity? Just look, S25. What is S25? S25, it will be 5, then 2, 7, 6, 13, 15 is also 15, right. Similarly, what is S235? S235, this will be this one, 5, 5, 10 plus this side is 14, 16. So, you please complete, I am not doing all of them. I stop here by just taking the one more, that is S2, 3, 4, 5, 6, it is this one, that is 17, right. But then there are many other cuts you can really generate, but then we have to cover many other things. So, if you look at only these many cuts, obviously there could be more, but we find that minimum is 14, and since I know, let me also tell you that this is the minimum, not because from only these many, but since I know, that is why I am writing. So, this one is the minimum cut, right. Really, to understand that or know that this is the minimum cut, you have to work out all possible cuts, and then see what is the minimum. So, this is the minimum cut. That means, what is we infer from here, that maximal flow possible in the network equal to 14. That is because we have the minimal cut. But then there should be an algorithm by which we can easily find out this without really going through like it is like maximal flow minimum cut theorem is giving me a quick result. Quickly we can know that is the maximum flow possible, but one need to know also that what are the flow patterns, how the flow is actually taking place. That is the second part of our question, right. So, in order to do that, we have to really follow a maximal flow algorithm. To the maximal flow algorithm, the first task before us is to find out a flow augmenting path. Now, what is a flow augmenting path? A flow augmenting path is a path from S to T, right, where a flow is possible. Say for example, if I go from S to 2 and then 2 to 5 and then 5 to T, can we get forward flow capacities in all of them? If we get, then that is a flow augmenting path. So, you see S to 2 to 5 to T. So, a flow augmenting path is a path from the source to the sink. If we go, then if a flow is possible, look here, the forward flow capacity is 9, a forward flow is possible. It is 6, a forward flow is possible. It is 5, a forward flow is possible. So, we can actually assign a forward flow in this path. If we can do that, then we call it a flow augmenting path. Alright. So, S to 2 to 5 to T is a flow augmenting path. So, first identify a flow augmenting path, right, and then see how much flow is possible through this, right. So, flow, what is the flow that is possible, what is the maximum possible flow in this particular flow augmenting path? You see 9, 6, 5, it should be the minimum of all the flow capacities they are available. That means, only a flow of 5 is possible. So, what we do? You assign that flow, right, assign that flow. So, if you assign that flow, basically what we need to do is we need to revise the capacities. So, we have assigned a flow. So, this will now become 4 5 because we have assigned a flow of 5, and these will become 1 5 and these will become 0 5. So, you see no more flow is possible here. So, flow of 5 is assigned. Now, find another flow augmenting path. So, can you see that we can have S3 6T, S3 6T. How much flow is possible through this? Look here 6 0, 5 0, 12 0. So, another flow of 5 is possible. So, again assign that flow. So, if you assign this flow 5 again, then we find this will revise to 1 5, this will revise to 0 5 and this will revise to 7 5, right. So, this flow is assigned. Now, another flow augmenting path, let us find S4 6T. How much flow is possible? 4 6T. Can you see? Because it is 2 0, a flow of 2 is possible, 5 7 5. So, only 2 flow is possible. So, again flow possible is to assign that flow. So, again this 2 0 will become 0 2, 5 0 will become 3 2 and this will become 5 7. What are we doing? What we are doing, since a flow of 2 is assigned, we reduce the forward flow capacity and increase the reverse flow capacity, because at this point you can reverse some of this flow, because a flow of 2 is assigned, you can take out some part of it. Originally the flow capacity was 0, but now it is 2, because a flow of 2 is going through this. So, you can reverse it. In that sense, the reverse flow capacity is now 2, because the flow of 2 is assigned through this arc. So, look at the slide, exactly that is what is done here, that flow augmenting paths are identified, and these are the 3 flow augmenting paths that I have already drawn for you: S25T, S360 and S460, and these are the maximum possible flows. Alright. And after these flows are assigned, the flow capacities are revised in this manner, right. So, earlier it was 90, now it is 45. Earlier it was 60, now it is 15, 5005, and this path 150557 from 6050 120 and 2050, so 0232, and this is because 2 are there, one from this side, another from this side. So, total flow is coming to 57, because from 12 a flow of 7 is assigned. So, this is what we do, we find out the revised capacities after flow is assigned as per the 3 flow augmenting paths. Is it all right? So, that is what we have done, that we have really assigned all the 3 through the 3 flow augmenting paths. But is there any more flow augmenting paths possible? That we have to understand and identify now. Now, let us look at whether some more flows are possible. You see, a flow of 1 is possible through here, right. Now, where from will it go? It will go through this and this and this. So, can you see another flow augmenting path is possible, that is S346T. S346T. So, you see 15433257. So, in the forward direction, maximum possible flow is 1, assign that flow. So, if we assign that flow, then we revise the flow capacities. So, from 15 it will now become 06, then 3443 will now become 34, and 46 will now become 23, and 57 will now become 48. All right. So, this is also assigned. Now, after this assignment, is there any more flow that is possible? You see, these two are not possible, because they are become 0 0, no more forward flow capacity remains. But here something can go, here also another one can go here, and look here, we can come back like this. So, S to 2, 2 to 5, 5 to 3, 3 to 4, 4 to 6 and 6 to T, right. So, another flow augmenting path is possible, that we might call S2, right. So, hopefully you can see S2 2 to 5 to 3 to 4 to 6 to T, S2 2 to 5 to 3 to 4 to 6 to T, S2 5 3 4 6 T. And how much flow is possible? 4 5 1 5 2 3 3 4 2 3 4 8. Is it all right? So, 1 is minimum. So, here flow possible is 1, assign that flow. Now, let us assign this flow and see what happens. 4 5 will now become 3 6, 1 5 will now become 0 6, right. Then 2 3, how much 2 3 will become? Look here, the flow is actually being assigned on the reverse side, that is 5 to 3, not on the forward side. So, 2 3 will become 3 2, because reverse flow capacity will reduce, forward flow capacity will go up, and 3 4 will now become 2 5, 2 3 will become 1 4, and 4 8 will become 3 9. Right. So, this is what is the maximal flow algorithm. Identify the flow augmenting paths and assign that flow and change the flow capacities accordingly as you assign the flows. All right. So, after we have done all these things, now very interestingly, can you see something very interesting? Look at these SN2 cut set. Can I draw this cut set now? See, this is the cut set. So, what are these cut set? This is S2 cut, right, or cut basically. So, this is the S2 cut, right. So, you see this particular cut set, I mean it is a cut set also, is there any capacity remaining? This has become 0, this has also become 0, this has also become 0. So, no, so what we call in the language that a cut set is exhausted, no more capacity is left, the cut set is exhausted. As a cut set is exhausted, no more flow is possible. So, what maximum flow minimum cut theorem has told us, that total flow possible would be 14 and the cut set was S2. So, after using the maximal flow algorithm, we have seen a cut set has been exhausted and that cut set has given us exactly a flow of 14 only, because 5 plus 5 plus 2 plus 1 plus 1 is 14, right. A total flow of 14 is that is possible, and the algorithm essentially works by really identifying the flow augmenting paths from the source to the sink and assigning that flow. As we are assigning the flow, revise the capacities. As you revise the capacities, then we are able to find out whether a cut set is exhausted or not. Moment a cut set is exhausted, we have no more flow possible and we have to stop, right. So, a quick summary of what we have done. Look at here, we have started here, this is the network flow diagram. We identify the flow augmenting paths and we found how much flow is possible. Then we assign those flows. As we assign, we revise the flow capacities. Say from 9 0 it is 4 5, from 12 0 it is 5 7, etc. As we assign the flow capacities, then the flow capacities are now revised. So, at this stage 3 are identified, further we identified 2 more, and like S to 3 to 4 to 6 to T, and S to 2 to 5 to 3 to 4 to 6 to T. And after assigning all these flow augmenting paths, we find a cut set is exhausted, and this is the same cut set which we obtained from the maximal flow minimum cut theorem. It's all right. So, no more flow is possible because the cut set is exhausted. So, these are the final revised capacities, and here is the final flow pattern also. How do we find? Look here, this is 3 6. So, it was 9 0, it has become 3 6. So, forward flow capacity reduced from 9 to 3. So, a flow of 6 is assigned. So, exactly this is what we do. The flow is 6, flow is 6, flow is 2, flow is 6, 1 is going in the reverse direction, flow of 2, 5, 4 and 9, right. So, 6 6 14, this 6 goes this way, splits into 5 and 1, this 6 splits into 6 plus 1 7, split into 2 and 5, this 2 and 2 adds become 4, 4 and 5 adds become 9, and this 5 and 9 14 goes to the sink. So, this is how we do the maximal flow problems we actually solve. Now, very quickly let us see an example of how a limited node capacity can actually be working out. Now, consider that node 5 has a limited flow capacity of 4 units only. Look at this particular network. The solution was through 5, how much flow is going through? 6 is coming, 1 is going out, 5 is going out. A flow of 5 is taking place through node 5. Now, if we say that node capacity flow of 6 is going through the node 5. Now, if we say that node 5 has a limited flow capacity of 4 only, right, then obviously this flow pattern is not possible. This is not possible because flow of 6 will not be going through this. So, how do we implement this? What we have to do? We have to really split node 5 into 2 nodes. One is 5, another is 5 dash. So, look here, that is what is done here. The node 5 is split into 5 and 5 star, and the capacity is shown as both sides 4, right, both forward and reverse flow capacities as 4. So, rest of the network will be as it is. All those things that were coming to 5, they are joined to 5, and all those they are going away from 5, they are now connected to 5 star. All right. So, this is the new network flow diagram. So, again we follow the same process. We find the flow augmenting paths, we find the maximal flows, right, and then revise the capacities. Then we find the further no flow augmenting paths, and then we see a cut set is exhausted. Which cut set gets exhausted? You know, you can very easily understand that it will involve 5 and 5 star, right, 5 and 5 star. So, you can see this is the cut set that gets exhausted, right. There is no more flow is possible. So, as you can see that, then you can you can see that this is the cut set that gets exhausted. Then because 0 here, 5 to 3 is 0, this is 0 and this is 0. So, this cut set is exhausted and no more flow is possible, and then this is the final answer, right. So, this is how, and now you have seen that node 5 is having only a flow of 4, right. So, this is how you solve maximal flow problem. Here is an exercise, you can do that. The another maximal flow problem, that example is given, and you can try out, find out the maximal flow pattern by using first maximal flow minimum cut theorem, and also find flow pattern by the maximal flow algorithm from source to sink. Right, do this exercise, and in our next class we consider what is known as the shortest path problems, right. So, thank you very much.